AMA, we're dealing with our last lesson in this unit on series. Our learning target, you can see, I can rewrite rational expressions using partial fractions, what we just did recently, and then I can evaluate what's known as a telescoping series. Let's just do some review. If you had 1 over k plus 2 times k plus 3, we could get a partial fraction decomposition by quickly saying, look, that whole fraction with two different factors in our denominator can be written as two unique fractions with the simpler factors in the denominator. So I have something a over k plus 2 plus b all over k plus 3. What we have done, and this is really just some review of what we were doing the last time, a couple of days ago, is we'd multiply through by that LCD, k plus 2, k plus 3, and everything on the left side is going to cancel. You just have a 1. As you distribute over here, you'll have an a times, well, the k plus 2's would cancel. You'd be left with a k plus 3. Right here with the b's, you can see that the k plus 3's are gone, and you'd have b times k plus 2. And tell you what, I'm going to rewrite this over here, just telling you that to find out what your a and your b really are, you can choose friendly values of k. So what's one value of k that we might want to plug in? Yeah, let's let k equal -3. Now, if we did that, this parenthesis right here would go to 0, and 0 times a would just be 0. Here, -3 plus 2 would be a -1, so I'd have b times -1. When I divide both sides by -1, you could quickly see that b would equal -1, right? What else could we let k? Yes, we could let k equal -2. Now, if we did that, of course, -2 plus 3 would be a 1. So this time we'd have a 1 times an a, or an a times 1. And this other part would cancel, and you'd just be left with a equals 1. What are we getting at? This partial fraction decomposition is going to be this. I'm going to have my a is 1, so I'd get 1 over k plus 2. My b is -1, so I could write it like so. And of course, sometimes kids look at this and they'll think, okay, so big deal, you've taken a whole fraction and you've separated it into two individual fractions. Why in the world would anybody ever even want to do that? Well, you do that a lot in calculus, and doing this can make life easier with calculus. But let's just see what would happen with this infinite sum for number 1. This infinite sum. We're going to add this up for forever. And to make matters more complicated, does this look like it's a geometric series? Does it look like my formula inside is, no, what we saw is the nth term was a sub 1 times r to the n minus 1. Guys, we're not getting that. This is not geometric. And it's actually not even arithmetic. It's neither. And you can see if it was arithmetic, guys, you would see, your nth term would be a sub 1 plus n minus 1 times d. You don't see a formula inside of sigma that looks like that. So you could say, well, my gosh, how in the world could we ever figure this out? Answer is do a partial fraction decomposition. And I'm going to write this as 1 over k plus 2 minus 1 over k plus 3. Okay? And that can seem rather silly at first. You can think, well, how is this helpful? Guys, here's what we're going to do. Let's just start writing out term by term by term what's happening. Plug in k equals 1. What's the first fraction that you see here? 1/3. 1 plus 2 is 3, so you get 1/3 minus, and then over here you'd get 1 over 4. So you get 1/3 minus 1/4. That's your first term. Let's plug in a 2. What do we get? 2 plus 2, you get 1/4. And then 2 plus 3, you get a 5. Let's keep going. Let's plug in a third term. K equals 3. What do we get? 1/5. And then we could say minus, well, 3 plus 3 is a 6. Let's keep going. Let's do another one. How about I plug in a 4? You'd get 1/6 minus 1/7. And this is going to go on and on and on and on forever. But I'm already hearing a number of students with that aha. They're saying, wait a minute, what are you guys seeing? Canceling. Look at that, negative 1/4 plus 1/4. Look at this, you got a minus 1/5. That's going to cancel with that 1/5. And this negative 1/6 is going to cancel with that. And it's just going to keep going and going and going. Hey, this 1/7 is going to get canceled out. Wow. Wow. What do you think we're going to wind up with for an answer? 1/3. This is called a telescoping series. Now, you might remember the movie Pirates of the Caribbean, right? And if you go back to those ancient days of sailing, you could see the captain of the ship very often would look and see an enemy behind. And you might have remembered they'd have their spy scope, right? And their spy scope would, be out here. But did you ever see them collapse it and then it just comes into this tiny little thing here? Yeah. Right? That's why it's called the telescoping series. This whole thing collapses like that spy scope. Because otherwise you think telescope, you think about looking out to the stars or something. No, that wasn't the analogy. Okay? We doing okay? All right, let's do another. We're going to do a partial fraction first. How do you know that it's likely telescoping? Well, you would hope to see a problem where you could do partial fractions. Look, I'm going to separate that to a over n plus b over n plus 1. I'm going to multiply through by the LCD. Kids get good with this in a hurry. I hope you can see that your a is effectively just multiplied by the denominator that it does not have, right? And same thing with b. Is everybody okay just up to this point? Let's be smart. Let's plug in some n values. 1 might be 0. Let n equal 0. And you'd say, well, then the b goes away and you have 1 is equal to a times 1. So a is equal to 1. Yes. Good. That's nice. And then you'd say, what else can I plug in? Negative 1. If I plug in a negative 1, this a term's going to go away. And then you'd have b times negative 1. And you think, well, my gosh, well, what's b? Divide both sides by a negative 1, you get that. So my a is a 1, my b is a negative 1. That means my sigma is going to be written as the partial fraction a over n, that's 1 over n. Now, when you have a negative 1 up there, it's probably easier to just write it like so, right? We all good? Let's see what's happening. Let's plug in a 1. You get a 1, you get 1 over 1. And you'd say, well, I get a 1, and then 1 plus 1 down here is a 2. So I'm going to say minus a half. Let's plug in a 2. 1 over 2 minus 1 over 3. Plug in a 3. 1/3 minus 1/4. You get the idea. We don't even have to keep writing this, right? You can see the canceling. You can say, look, this minus 1/2 cancels with the positive 1/2. This minus 1/3 cancels with this positive 1/3. This minus 1/4 would cancel with the positive 1/4. And it's just going to keep canceling forever. Forever and ever and ever. What's left? Answer is 1. Okay? We doing okay? Telescoping. All right. Now comes the surprise. Would you look at this telescoping series for number 3? And kids can understandably say, I beg your pardon, Mr. Dobner, that's not a partial fraction. And we're not even going to need a calculator. Yeah. Here's why I want to give you a reminder of. Here's a reminder. Friendly reminder. log base b of m all over n is log base b of m minus, oh, hey, look at that. Right? Right? So what are we saying? This sigma, it's not infinite. Be careful. Be careful, guys. You don't have to see this go up to infinity. Right? So we're going to plug in a 1 and just see where we start. We're going to say log base 10 of 1 minus, plug in the 1 plus 1, and we'll get a log of 2. Plug in your second term. We'd have the log of 2 minus the log of 3. And plug in a third term. We'd say, well, I'll have the log of 3 minus the log of 4. Why? Because, that 3 plus 1 becomes a 4. You could keep going. In fact, I don't think you guys even need to see this keep going. However, please understand there is a stop. Yeah, you could say, look, at the end of the day, my last term, I can actually see this one. That's the log of 30 minus the log of 31. Right? Now, what's going to cancel? Well, the log 2s are going to cancel, right? The log 3s are going to cancel. The log 4s are going to cancel. And notice what just happened. Please pay attention. Please pay attention. If I stop there, do you see how it's the first term in the parenthesis that got canceled? That's what's happening here. You see that? So what's left? Everything's gone except the log of 1 minus the log of 31. By the way, what's the log of 1? By the way, you're saying 10 to what power is 1? 0, right? This is 0, right? So it's 0 minus the log of 31. That's just negative log of 31. Look at that. That's what you converge to. That's where you're going. Is it telescoping? Yes. Is it an infinite telescoping series? No. Back of the notes, we have a worksheet. And for the worksheet, we're going to do the odds.